Certify is a data quality engine tool where data quality checks can be performed both data at rest and in motion. The moment you enter your credentials, it's going to authenticate either with the database or through single sign-on. It can be integrated with Azure Active Directory as well. When you log in, it's going to take us to the connection page where we have to first register our connection to wherever the datasets reside. So, if the datasets are present in ADLS, we will register the connection for ADLS. To register it, we need the storage account, connection string, account key and the container name to which we connect to. Once connected, it will store all the metadata information in the backend Postgres tables. There are various connectors that we're supporting. When the connection is ready, we have to register the assets by going to the Data Quality Assets tab. When we click on Register New Asset and choose the connection we have created, we list the directories and files that are present inside the directory. You can either register a single asset or multiple assets. When you submit, the backend is going to sample the data profile and then recommend rules based on that dataset. This is the graphical representation of the dataset that it has been registered. For each dataset, we show basic information such as the dataset attributes, the record count, and from which connection this dataset has been registered. If the asset has any tags, the solution shows the tag count. Whether there is any data quality check that it has been performed, and the data quality score of that particular asset. When you toggle to toggle mode, you can see the attributes the asset has registered. During the asset registration process, machine algorithm models read the dataset and automatically assign tags with a confidence core. If you feel that the tag that it has recommended is appropriate, you can go ahead and add the tag to this column. When a tag is added, we can associate rules for each tag, and this can be applied on any dataset. Also, when we're creating the sensor, the rules will be automatically recommended. When the asset is registered, we are profiling the dataset. In the profile, we have basic information such as what are the attributes on how much of data this profiling has executed and what are the various types of data in the asset. Based on the profiling information, we recommend rules. Suppose this column has a missing value. In that case, the tool automatically recommends values to not to be null, and if it is an integer column, it's also going to recommend values between recommended rules. If it is a category, then it will recommend values based on the categories. That is the advantage of the profiling. The Data Quality tab shows you the scores after the data quality checks has been executed. We are also maintaining the history of how many times the data quality checks has been performed on the asset. For instance, here, we show the anomaly on the integer type of columns. If there are any anomalies, we highlight them and you can click on them to see more details. The asset registration is going to be executed daily, and we are going to calculate the minimum, maximum, and average value of the integer columns. We then compare today's data with yesterday's data and then identify the record as an anomaly. This is how we identify the anomaly. We also calculate the correlated columns and then identify the anomaly. Suppose that amount and price are correlated. Whenever there is an anomaly in the amount column, we expect an anomaly in the price column too. When we run the data set, if we do not observe any anomaly, we will highlight it. This is how the anomaly is calculated, and we also show the anomaly in a tabular format. Records that have anomalies are filtered, and we show which column has which anomaly. For this record, we can see that the anomaly column is showing as amount. So, the amount value is highlighted as an anomaly, and for the multivariate, we can see that these three columns are correlated. Therefore, there is also an anomaly for this record. This anomaly detection all happens during the asset registration process itself. Once the asset is registered, you can create the business term if needed. For instance here, there are around 15 to 20 business terms, and I can associate the rules to each business term. For example, you can create a tag called email and an associated rule. This is how you do this. The tool supports over 40 rules out of the box. These rules can be applied to column entity and multi-columns. These are also classified into different categories like accuracy, consistency, timeliness, and completeness. We can also create a custom rule based on an existing base rule. For instance, if we have used the values to match regex rule, we can create a rule for US phone validation number bypassing the regex pattern. This rule can be applied when we are creating the sensor based on the auto tag recommendation. Now we have our asset ready and then the rules that are to be configured. The moment you create a sensor, it automatically recommends rules based on profiling. For instance, for this total price column, we have added a tag called money. Whatever the rules that are configured for money, those will be automatically recommended when we are creating the sensor. For this money, we are going to check if this value has 2 decimal. We have applied the regular expression for that, and this rule can be applied on this particular column. Apart from this, we have an option to add custom rules. The first one is condition-based rules. For condition-based rules, you can apply a rule by filtering the dataset. You select a rule you want to apply on that column and then you choose a row condition to fill in the values. This will filter based on the row condition and then apply the rule on top of the filtered dataset. This is the advantage of condition-based rules with regards to referential integrity. This is nothing but the foreign key relationship check key. For this, the rule checks the values in this dataset and compare it with the other dataset or table. When you choose any asset, we are going to list all the columns that that table has, and then you configure the rule. All the rules showed so far are only to column-based rules. We also have entity and multi-column-based rules. These are applicable to the whole dataset. For example, the column count should be between, columns should match an ordered list, multi-column sum to equal, or column pair values to equal compound columns to be unique. We also have custom entity-based rules. The first one is the empty table check. You can check if the table or file has any empty records, and the second one is the row count difference. The row count difference can be calculated for today's data. The comparison is done between today's and yesterday's data, or the average row count where you can specify the variance percentage and then check. Another type of rules is query-based rules where you apply custom SQL rules. You write your own SQL query by providing the rule type and by writing your regular SQL query. When all your rules are configured and you save changes, the sensor is created. You can then execute the sensor immediately or schedule it. To execute the sensor, you have an option to choose the engine. You can either choose the Spark or the Python engine. The tool currently supports a total of 3 execution engines. If in your sensor you have configured some custom SQL rules, when you choose Spark engine, the custom SQL rules that you have configured are being converted to Spark SQL and then we are executed in Spark. We have a SQL engine too. If your dataset supports SQL-based queries execution, in the backend we are going to reroute it to execute it using the query push-down approach on the SQL database. We are also going to maintain execution history, and when you view results you will have access to the statistics and summary of all the validations performed by the tool. The statistics show you all the rules, how many are executed on this dataset, how many are successful or unsuccessful, and the overall success ratio. It will also show on how many records this rule have been executed. When custom SQL rules have been executed, if that validation failed, we'll show how many records failed and what values this query failed on. We also show rules applied on a single column, the configuration for each them, and if it failed, how many records failed, and because of which values it did. You can also download those reports to a CSV file. We also have the option to reject records if the validation failed. We can filter them and give the failure reason and the column this record failed on. If a single record failed because of one or more columns, then we highlight that record, what rule was applied on that column, what is the configuration, and of course the values that failed. Similarly, you can download it to a CSV file too. When the execution is complete, the data quality dashboard will show the overall DQ score and the score calculation for each classification such as accuracy, score consistency, how many rules were executed, what was their success ratio, on how many assets it has been executed. This graphical representation shows the data quality both monthly and dimensionally. It also shows data quality scores and how many rules were executed. You can also filter for your asset by selecting the zone and the entity and filter the results accordingly and show their statistics. We have an admin page where we can create users and assign roles. We also have extensive back-end and front-end documentation you can leverage.